Good evening and welcome to the Exploratorium and to tonight's Everything Matters, Tales from the Periodic Table. Tonight we are doing the element cobalt. This is the 27th edition of Everything Matters. I would normally say I hope that you all got your collectible card for cobalt. Unfortunately, our printer didn't get the card to us in time for tonight's performance, so we will have cobalt next month. So next month, we hope you'll come back and see nickel and collect your collectible card. It'll be collectible at that point too, for cobalt. But right now you can go on the tables back there and you can fill in your collection for the first 26 elements, which goes up to iron. Unfortunately, we don't have cobalt for you tonight. How many people have been to After Dark before? Wow, that's a pretty good number, pretty good number. If you enjoy After Dark, I have to be just sort of a little bit blatantly commercial here and let you know that we have a special After Dark membership at the Exploratorium now. For the one low cost of membership, you can come to 52 After Darks a year. It's a really good deal. It's like less than $1 per After Dark if you buy the membership and you come every week. But really, really a good deal, because I always enjoy After Dark, so I would buy one if I didn't have keys to the building. So I'm Ron Hipschman. I'm your host for Everything Matters, Tales from the Periodic Table. And our program tonight's about 60 minutes long. It's divided into two parts. First, I'm going to talk about kind of the chemistry and the history and some of the common applications that cobalt has. And then I'm going to be followed by Forrest Lesh Middleton. And Forrest is going to share his unique making process with cobalt blue. You'll be seeing a lot of cobalt blue tonight, as well as his efforts to address the element with social awareness and responsibility. So I'm just going to start off right now with cobalt, and we'll invite Forrest up in just a bit. So cobalt is the 27th element in the table. Can everyone spot it there? Sure you can. That's right there. There's cobalt. It's element number 27. That 27 is the atomic number. It's how many protons are in the nucleus of cobalt. There's, of course, neutrons in there as well, but there are variable numbers of neutrons. But if there's 27 protons, that means there's 27 electrons, and it's cobalt. It comes from, the name cobalt comes from a German word, kobold, and kobold. And kobold really means goblin. Kind of was pictured like this if you try to find some ancient etchings, and they're really, really hard to find these ancient etchings because kobold has been sort of taken over in the modern era by Dungeons and Dragons, and so it's really hard to find the etching pictures because they're all Dungeons and Dragons pictures right now. And kobold means goblin. For the ore that you refine cobalt from, cobalt is normally associated with arsenic and sulfur, and when you try to smelt the cobalt from the ore, not only do you get cobalt, but you get this stuff that contains arsenic and sulfur. And so this became goblin ore, and we call it cobalt. So that's kind of where the name came from. It's been known not since ancient times. As a matter of fact, cobalt was one of the very first elements that was refined and discovered, as opposed to some of the other elements that were before it, which were known to occur in nature, like copper and carbon and all those others. So it was the first metal to be reduced. It's the first new metal, really, that was discovered. It was discovered by a fellow named George Brandt. Unfortunately, we don't know what he looked like, so I'm just going to have to put a silhouette up here for you. But he actually synthesized the element around 1735. It was, again, previously an unknown element, unlike some of those others that were known around the time, like bismuth and, let's see, I have a list of them here. Bismuth and other traditional metals, iron, copper, silver, gold, zinc, and mercury. Those all occurred kind of naturally. But George was the first person to actually discover a brand new element not known to the ancients. Cobalt's been known for centuries and millennia, actually, as a colorant, producing deep blues in glass and ceramics, and we'll talk a little bit more about that. The cobalt is mined from a few different kinds of ore, mainly cobalite, which is a cobalt arsenic sulfide. And that is that cubic one over there. Kind of reminds me, if you were here last month for iron, we looked at iron sulfide, which is also called pyrite or fool's gold, and it also is kind of cubic in nature. And so that's sort of the main ore that it's mined from, and also the others are glaucodot and erythrite. And I have a couple others that contain cobalt. This is really heavy. If anyone should come up and lift this, this is scudderite. I'll hold it really still so we can get a shot of it here. Maybe we can get it up on this. There we go. And scudderite has these beautiful kind of octahedral crystals as well that are just quite nice. And the other mineral that contains cobalt, Esther, our buyer in the store, found, she just went to the Gem and Mineral Show in Tucson, this giant gem and mineral show once a year in Tucson, and she found this ore too, which is it's a cobaltocalcite, and it's, I don't know if you can catch it, but it has kind of this pinkish color to it, and these beautiful calcite crystals as well. So she was on the lookout for cobalt things for me. Okay, we'll take that. There we go. So cobalt, as I mentioned, is mined. It's found in many places in the world, but its main source is in the Democratic Republic of Congo. And so there is a problem of ethically sourcing cobalt, especially from there, because they have a lot of child labor working on collecting it. But it is found elsewhere in the world, but most of it still comes from the Democratic Republic of Congo. There is a place, you know, it's like there in Canada, there's a little blue dot up in Canada, which is really interesting because if you go there, it's often mined as a byproduct of silver mining because it occurs with silver. And there's this little town up in Canada that's called, oddly enough, Cobalt. And it actually has become kind of a ghost town, but because cobalt is in such high demand now, that town is sort of beginning to come back a little bit. So that's kind of good news, except, of course, you're mining, but we do need cobalt. It's actually, if you look at the production of cobalt over the years, you can see that we're using a lot more of it now than we ever have before, mainly because it's used a lot in batteries as one of the cathode in lithium batteries, which I'll show you in a little bit. So, if we look at the abundances in the universe, it's not totally abundant. It's the 19th most abundant element in the universe by mass. If we look in the sun, it actually is the 20th most abundant element in the sun. In meteorites, it's a little bit more abundant. It's the 17th most abundant element in meteorites. But if you go to the crust of the Earth, it goes way down. It's like the 29th most abundant element in the crust of the Earth and the 41st most abundant in the oceans. But if we go to our body, well, it's the 38th out of 41 elements found in the human body, and it's way down there in abundance in the human body, and it actually appears in vitamins, and we'll get to that. It's made in stars. There's cobalt, and it's made inside of exploding stars. And the fact that we see it in our sun means that our sun formed from the stuff that was left over from stars around us exploding, because there's cobalt in the sun. You can't make it any other way. So it's kind of, our sun is not a first generation star, and that's one of the reasons you can tell. Now there's many different forms of cobalt. When you have different forms of the same thing, you have something called an isotope. And an isotope, iso meaning same and tope is place. So the same place, it's the same place in the periodic table, but there's different numbers of neutrons in the nucleus of the atom. So some have more neutrons and some have less neutrons. So here you can see the number that you see there on the chart, the 47 through 75, is the total number of neutrons plus protons in the nucleus. So it's Cobalt, which has 27 protons. If you just add 20 more neutrons, you have cobalt 47, but cobalt 75 has a lot more neutrons in the nucleus. Those are, for the most part, radioactive. There's only one stable isotope of cobalt, and that's cobalt 59. Cobalt 59, since there's only one stable isotope, obviously cobalt 59 is 100% of the natural cobalt, but those other isotopes are all radioactive, and some of them are longer lived and some of them are shorter lived. Just give you the 4 longest lived ones here from cobalt 56, 57, 58, and 60, because 59 is stable. Cobalt 60, which we'll talk a little bit more about, has a half-life of 5.3 years. When I say half-life, if I had a lump of cobalt 60 in my hand, which you should be very happy that I do not, intense gamma ray emitter, in 5.3 years, half of that lump would be gone, and in another 5.3 years, half of what was left would be gone, so a quarter would be left. And in another half-life, there'd be an eighth left, and a 16th, and a 32nd, and a 64th, and so on. So a half-life tells you how long does it take for half of any given lump to disappear, to disintegrate. Cobalt metal, well, it's just this grayish, silvery metal. Looks like this. This is a piece of cobalt, just a little chunk of cobalt, and I have a couple more little chunks of cobalt in my... I'm going to keep them in baggies for you guys because I don't know if there's any allergy, cobalt-related allergy. I'll just hand them around here so you can see the heft of these pieces of cobalt. It's pretty dense. It's got a good heft to it. Cobalt has a density of 8.9, almost 9 grams per cubic centimeter, which is, remember what water is? Anyone remember what the density of water is? It's 1 gram per cubic centimeter. And you can see that iron, which is also on this chart, on this slide here, is about 7.8 grams per cubic centimeter. So this is denser than iron. I don't have a cube of cobalt for you. That's all the cobalt I have. But I do have cubes of different density materials here on the table, which after the talks, you should come up and try to lift, because I have lots of different densities up here. I have everything from tungsten at 19 grams per cubic centimeter, to lead, to copper, to titanium, to iron, to aluminum, to magnesium, and cobalt is sort of up there, sort of in the middle-ish. It's the purple dot there. So cobalt is mid-density. It's fairly high density, especially if you take into account all the gases down here, but there's pretty much 0 grams per cubic centimeter. Cobalt is a moderately soft metal. If we look at where it is, this is the famous Mohs scale of hardness that if you're a geologist you know about. And all the elements here are labeled in white, and the other ones are kind of minerals. But you can see that cobalt is right there around the middle of the table, 5.5. Glass is harder. You can scratch cobalt with glass. So it's a little, excuse me, it's a little soft, but it's not too soft. An interesting thing about cobalt, though, is that if you find a magnet, cobalt is actually ferromagnetic. It sticks to magnets. There aren't many elements that do that. Iron, we know iron does. Cobalt, nickel, next month, and much weaker. There's a few that are much, much, much weaker. Probably wouldn't even be able to lift their own weight. Gadolinium, a rare earth, is also ferromagnetic. So that's kind of an interesting aspect of it. And all elements that are ferromagnetic, if you heat them up at a certain temperature, they lose their magnetic ability. And that temperature where they lose their ability to stick to a magnet is called their Curie point, the Curie temperature. And cobalt, interestingly enough, is way up there. Has the highest Curie temperature of all the ferromagnetic elements, very, very high at 1,300, almost 1,400 degrees Kelvin. So it's unusual in the fact that you can heat this up a lot more than you can iron before it loses its magnetic properties. Cobalt's a moderately expensive element, $31 a pound. Not too expensive. It's not gold for certainly, and but it's not iron either, which is like 25 cents a pound. It has a medium-sized atom. Oops. Yeah, that's right. A medium-sized atom. I always compare to hydrogen. But cobalt is kind of in the middle as far as sizes of atoms go. Hydrogen's pretty small because it only has one proton, one electron. If we actually look at I love charts. I'm sorry, I'm going to apologize ahead. I just love charts. And here's a wonderful chart. This one shows with increasing atomic number, so hydrogen, helium, lithium, beryllium, boron, and so on, up to the higher numbers. I think this probably goes up to uranium or something like that. The atoms, they kind of get big and then they get small, then they get big and then they get small, then they get big and then they get small. Hydrogen, of course, is the first element, so H is right there, and it's in the periodic table up here. You can see helium is actually the smallest atom because its electrons are held very tightly, and it's a noble gas. All the noble gases, we'll talk about that in a moment, are very tightly held as far as their electrons go. But look at these giant atoms up here, there. Actually, let's see where cobalt is first. There's cobalt right there. But all those ones at the very top, the big giant atoms, those are the atoms that only have one electron in their outer shell. So lithium, sodium, potassium, rubidium, cesium, the ones that are over in the left-hand side of the periodic table, they have that one electron flailing out there on the outside of the atom. And so they tend to be really, really large. Whereas the ones down at the bottom here, those little tiny small atoms here, those are the atoms that hold onto their electrons very tightly, that have complete orbitals, and those are the noble gases, so helium, neon, argon, krypton, xenon, radon, and they're over on the right side of the table right here. So I thought that was kind of an interesting chart with these metals right here, the transition metals sort of between the two. This is sort of the middle of the table right here. Cobalt does have it's a kind of an uninteresting spectrum, frankly. There's no bright lines like sodium has yellow, and hydrogen has a nice red and a cyan and a violet line, and mercury has these really nice lines, but cobalt's frankly kind of boring. But I'll show it to you anyway. But speaking of colors, cobalt is responsible for many very interesting colors, mainly blues, and it comes from cobalt aluminate, COAl2O4. And that powder looks like this. And this powder will be mixed in with, for instance, glass to give you cobalt glass. So here you can see a cobalt bottle, and on the over the side over there, there's a cobalt insulator, which Kevin just came and gave me one of. Look at this. Someone gave me this tonight. Isn't that nice? It's a cobalt blue insulator that came off of a power pole. I hope you didn't go up and take it off a power pole for that. But it's very old. This was patented on May 2nd, 1893. So that's a nice little antique there. Oh, I'm sorry. Should I hold it up for you? Can you see it? I did. I forget to hold things up long enough. Okay, there we go. Maybe put a card behind it so you can see the color behind. Maybe that doesn't work very well, does it? Well, it's not better. A little bit better there. Beautiful insulator. Okay. Cobalt glass, many people collect it. I found it's really easy to collect if you just drink Sky vodka or Harvey's Bristol Cream sherry. But here's some antique. Oh, this is a bromo seltzer bottle. Bromo seltzer used to come in cobalt glass bottles. There's whole books. There's collectors of cobalt glass items. So you can actually go out and get. I just looked at Amazon and found these cobalt glass books. Just beautiful. I think it's beautiful stuff. I just love the color of this cobalt glass. It can also be used for glazing and pottery, and Forrest is going to talk a little bit about that to us. I just have a few examples here of cobalt glazed pottery. This, very well-known Delft tiles and Delft artwork from the Netherlands. And in China, way back in China, cobalt was used as a colorant in the glazing of like these vases, for instance, vases. Cobalt, for artists, is very well known as a pigment. Here is cobalt blue paint. However, most cobalt blue paint contains no cobalt. You can get it. It's really expensive, but most cobalt paint does not contain cobalt aluminate, but rather contains a different chemical called, okay, I have to read this one. I think it's phthalocyanine. I don't think you pronounce the PH. Phthalocyanine blue, which, as you can see, has no cobalt in it. It does have a copper atom in the middle of it, however. So that is responsible for this color blue. I couldn't find any cobalt paint at the art store. They don't have it. There is, coming up, in next year's series, there's a brand new blue pigment was just discovered that uses the element yttrium. Can you imagine my delight when I found something else something that uses yttrium? So I'm really happy about that. Well, I'll have something to talk about when we get there. High-speed steel. High-speed steel bits use a iron cobalt alloy, and these are much tougher as far as the strength. You can drill high speed and much harder materials with this. You can tell these bits because they have kind of a yellowish tinge to them. If you look at them compared, it's kind of hard to tell here, but if you compare it to just a side by side with a standard high speed drill bit, these are kind of yellowish in color. They're not bluish, they're yellowish. Cobalt chrome alloys are used for biological things. Here they are cutting out crowns from cobalt chrome alloy. And I don't know whether this is it's like it's an amalgam, or I don't know if it's actually cobalt and chrome that actually chemically bond together. It may be just an amalgam, I'm not sure. It's also used in artificial hip and knee joints, this chromium cobalt alloy. One of my favorite uses of cobalt, however, is in magnets. This magnet here is a cobalt alloy, as are these magnets here. These are all cobalt alloys, and the alloy of this is an alloy called alnico. Alnico. You'll never guess what chemicals are in, what elements are in alnico. Want to take a guess? Let's start. Aluminum, nickel, and cobalt, yes. So we are going to see these magnets next month too. I'm just going to reuse this slide next month. The middle one there, everyone's familiar with the horseshoe magnets, but anyone know what this is? That's a special kind of magnet that's called a cow magnet. A cow magnet? Doesn't look anything like a cow, I hear you say. Well, actually, these are used with livestock. Let's bring in Bessie here, Skid, okay. They put these magnets in the first stomach of cows, because cows are, well, they're not the brightest animals, and they eat staples and barbed wire and things like that, and if you allow that stuff to get into the digestive tract of the cow, it causes something called hardware disease, because it punctures the intestines. And so by putting a magnet in the first stomach of the cow, it collects all of the hardware, so it doesn't proceed down the digestive tract at all. So these cow magnets are they're Alnico magnets, and they're really good magnets. We might even have them in our store. I'm sure we do, as a matter of fact. So you should check that out. Let's get rid of Bessie here. There she goes. Okay. Cobalt is used in some really super strong magnets. These are not the strongest magnets. They're kind of the magnets of my youth, the good old horseshoe magnets. But you can make super magnets. Those are called rare earth magnets. And one of the types of rare earth magnets uses samarium and cobalt. Samarium is a rare earth. It's in one of those bottom rows of the periodic table. And these make like really, really strong magnets. These are the these aren't just the finger pinching magnets. These are the finger removal magnets if they're very large. You have to be very careful with these kinds of magnets. So where else is cobalt used? One of those isotopes, I mentioned it briefly, cobalt 60, is a radioactive form of cobalt. It was first synthesized by this gentleman here, Glenn Seaborg, who was over at UC Berkeley. And actually, he was involved in the synthesis, discovery, and investigation of 10 elements. It's pretty good, huh? Let's see, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, and element 106, seaborgium. Glenn Seaborg. He actually had an element named after him. And he did earn his share of the 1951 Nobel Prize in Chemistry for all the work he did in elements. All the ones he discovered had to be made. None of them occur in nature. And it's odd how you notice how many of them are named after the University of California. There's californium, there is americium, there's berkelium, and lawrencium, because it was Lawrence. Back then it was the Lawrence Radiation Laboratory. Now it's the Lawrence National Laboratory, Lawrence Berkeley Labs. But Glenn Seaborg did all of his work over there. So quite an interesting guy. We'll be getting back to him in about 10 years when we get up to those elements. Cobalt 60 has to be made. Doesn't occur naturally, because with a half-life of 5 years, it all decays away. So it has to be made artificially, and it's made in reactors. Specifically, most of it is made in the Advanced Test Reactor in the Idaho National Laboratory, another national lab, sort of like the Berkeley Lab. It's located right there, way out in the middle of nowhere, literally for a reason. And they have a big reactor there, which, going with our theme of blue tonight, it's made inside of this reactor, and here you're actually looking down into the active core of the reactor. Now, it's not blue because of cobalt. It's blue because the gamma radiation, the radiation is coming out and actually moves faster than the speed of light in the water there. And when it does that, it gives off a specific kind of radiation, light, called Cherenkov radiation. And that's that blue glow you see inside of reactors, but it has nothing to do with cobalt. But all of this cobalt 60 is used primarily in radiotherapy for cancers, specifically brain cancers. And this gamma knife, these giant machines where they put a source of cobalt 60 up here, and they shine the gamma rays down to you on the table, and they can make a very small beam, and so they can really zero in on just the tumor. It's used to brain metastases, arteriovenous malformations, we're just reading here, facial nerve pains, meningiomas, and lots of different basically cancers that are hard to operate on. And you expose with that machine, and the machine moves around you, so the part that it moves around, you don't expose anything on the outside, but where it's focused on the very inside is what gets the highest dose. So that's why it has to have a big thing that moves around. Really interesting machines. I mentioned batteries, lithium batteries. One of the cathode of lithium batteries usually involves cobalt in some form. And in the human body, and basically also in nickel-cadmium batteries, nickel metal hydride batteries, they also have cobalt that improves kind of the oxidation of the nickel in those batteries. So, but mainly the lithium batteries, which we use most of now in electronics and electric vehicles, that's what's really pushing the mining of cobalt now. Forms the positive electrode on the battery. So in the body, there's not a lot of cobalt in the body, but what's there is in the form of B12, the vitamin B12, and you can see there's the cobalt atom sort of sits right in the middle of that molecule, pretty complicated molecule. So with all of that, I want to end with Mary Soon Lee published a list in Science Magazine of elemental haikus. So the one for this month is traded from Persia, a blue more precious than gold for a Chinese vase. I really like ending with a haiku. So next month is nickel. We hope you come back for that. Element number 28, March 15th at 8 o'clock. Whoops, I don't know what happened there. That was interesting. Also, I do another lecture series called, you can bring me back. I do another lecture series called called Full Spectrum Science, and this month is the last doubling. We're going to talk about the exponential function and why you should know about the exponential function. It's probably the one mathematical thing you absolutely need to know about. So we're going to talk about that. So stick around. We're going to bring Forrest up here, and we're just going to have to do a little dance with the presentations here, but please stick around and we'll be back in just a moment. Thank you for coming.